exercise 3.1. Exercise 2 points. I think that exercise is quite okay, so I will send it in the old videos I've done before. And before you get to our practice activity 3.1, rather, you should have done activity 2.1. So definitely you must have seen it, right? Exactly. So this one is practical activity 3.1, working with experimental data. We want to check for precision and accuracy. Is that okay? Precision has to do with the degree of reproducibility or repeatability of measured values, while accuracy has to do with how close the measured value is to the true value. And that is what we are trying to do using this particular, try to ascertain rather using this particular practical. So the question is, calculate the readings of the small subdivisions of devices A, B, C, D, E, F, G, and H in figure 3.1a and 3.1b, and devices A, B, C, and D in figure 3.2. Now, if you check your manual, in page 15, you have 5 cylinders there. They are labeled A, B, C, D, E. Now, if you look at the 5 cylinder, the first cylinder is a very small cylinder. It is calibrated 1, 2, 3, 4. Now, in between 1 and 2, if you count, there are 10 values there, or there are 10 marks there, rather. If you count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, in between 1 and 2, there are 10. So, we can now say that to calculate the smallest subdivision is going to be the values you have there, each of them consecutive minus each other. So what we had there was 2. It's going to be 2 minus 1 all divided by 10. And that will give us 2 minus 1 is how many? 1 divided by 10. So for A, the smallest subdivision is 1 divided by 10, which will give us what? 0.1. What is the unit? Milliliter. So for that one, the smallest subdivision is 0.1 milliliter. Is that okay? Now, let us look at the second one. The second one, which is B, is calibrated 2, 4, 6, 8. And in between each of them is also 10. So it's going to be 4, which is the highest there, minus 2 divided by what? 10. 4 minus 2 will give us how many? 2 divided by 10, which will give us what? 0.2 mil. Is that okay? Then the other one, if you look at it, C, is 5, 10, 15, 20, 25. So it's going to be the value you have there, the second one, 10 minus 5 divided by, in between 5 and 10, we have 10. 10 max. So divided by 10. 10 minus 5 is how many? 5 divided by what? 10. And that will give us what? 0.5 milliliter. Is that okay? So that is that for each of them A, B, C, Ds. First one is 0.1 milliliter, 0.2, 0.5 milliliter, and so on. Then the other one for D is calibrated 5, 10, 15. So 10, 20, 30. That is 10, 10 each. So we are going to have, let's do 10 and 20. It's going to be 20 minus 10 divided by 10. This one you could just copy. There's no need because everybody had the same thing. 20 minus 10 divided by 10. 20 minus 10 will give us how many? 10. And then divided by 10, my dear student, that will give us how many? 1.0 milliliter. So the smallest subdivision will be 1.0 milliliter for this one. Then for E is 20, 30, 40. So let us take 20 and 30 and use that one to solve. So it's going to be 30 and 20. So 30 minus 20 divided. If you check, in between each of them is also 10, 10 units or 10 marks. So everything is divided by 10. 30 minus 20 will give us what? 10 divided by what? 10. And that will give us how many? 1.0 milliliter. That is for E. So we can see that E and D, they have the same thing approximately. Is that understood? Now, the next one, this is 1, 2, 3, 4, 5. Okay, it's correct. But why is this one now 50 mil and this? Okay. The next one is F. For F is 70, 90, 90, 110. So let us use 110 and 90. So it's going to be 110 minus 90. In between each of them is also 10 units. So you say divided by what? 10. And that will give us 110 minus 90 will give us 20 divided by what? 10. Is that okay? 20 divided by 10 will give us 2.0 milliliter. All right? And then for G is 200, 250. So we are going to take 200 minus 250 first, minus 200 divided by 10. 250 minus 200 is 50. So we have 50 divided by 10, which of course is 5.0 milliliter. Then for H is 500, if you look at it, minus 400 divided by what? 10, because between each of them is 10 marks. Will be 500 minus 400 will give us what? 100 over 10, which will give us what? 10.0 milliliter. Is that okay? So that is that. Now, they say rank the device in order of precision. That is from the lowest to the highest. Rank the device in order of precision from the lowest to the highest. That's a very simple thing to do. All right? Coming. From the least to the highest, we have it coming from, okay, in increasing order. Now, the higher this value, the less precise it is. The higher this value, the less precise it is. The lower this value here, this value of the smallest subdivision, the more precise it is. So my dear student, if you can see H is higher, so it's going to be H is less than, the other one is what? G. G is about 5, which is less precise. Then followed by what? F, which is less precise than, of course, E. E is this. Are you getting it? E and this one, they are the same. So we just take it E, which is, of course, less precise than D, less precise than what? C, less precise than B, less precise than what? A. So it means that at the end of the day, A is the more precise instrument among every instrument you have here. Because the smallest subdivision of A is 0.1. So it will measure values very close to their actual values. Is that understood? A will measure values very close to their actual values. All right, so that is that for that particular one. Then if you go to this same table, you have another one, figure 3.2, which has to do with meter rules. Are you getting it? Then for the meter rule, you have 1 also, 1 and 2, and then in between them, there are, I think, the lines here are not too obvious, but then we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Each of them is 3, 3, which is 6. So this is 1, 2, 3, 4, 5, 6. Between each of them is 6, 6, if you look at it very well for the calculation. All right, so if you look at the other one, figure 3.2, you have A, B, C, D. Now for the first one, it is calibrated 1, 2, 3. So if we take 2 and 1, 2 minus 1, divided by the subdivisions in between them, or the mark in between 1 and 2, is 6. If you look at your manual very well and count, you will get 6. 1, 2, 3, 4, 5, 6, although it's not too clear. So this is divided by 6. 2 minus 1 will give us how many, my dear student? 1 divided by what? 6. And 1 divided by 6 will give us what? So we have 1 divided by 6, which of course will give us 0.16. Is that okay? Then the next one is also calibrated 1, 2, but there's only one subdivision in between them. Is that okay? So we take the first one, which is of course 1 minus 0. There's a lot. Let's take the second one, 2 minus 1. There's only two subdivision, because after that one you have 1, 2. Two subdivision in between them, which is 2 minus 1. This will give us 1 divided by what? 2. 1 divided by 2 will give us what, my dear student? 0.5. Is that okay? 0.5. Now, what are their units? You must include their unit. The first one is in centimeter. The second one is in centimeter. Then the other two, they are in inch. Now, if you look at this other one, it is half. So you have half minus 0. Half is still the same as 0.5. All right, so I can write 0.5 minus 0 divided by, between 0 and that half, how many points do you have? If you count, this is like 1, 2, 3, 4, 5, 6, 7, 8. About 8. 1, 2, 3, 4, 5, 6, 7, 8 is all over 8. All right? So that at the end of the day, the smallest subdivision will be 0.5 minus 0 will be 0.5 divided by what? 8. And 0.5 divided by 8, that will give us 0.625 in inch. Is that okay? Then for D, the same thing, but this one had just only one subdivision in between. So it's going to be 0.5 minus 0 divided by only one subdivision. Me? Yes, only one subdivision in between. So this will be 0.5 divided by 1, which of course gives us 0.5 inch. So these are the subdivision for this particular one. All right. Now the next thing is to calculate the equivalent in millimeter, because you need the equivalent in millimeter in order to calculate their precision. To calculate the precision for this particular one thing I would like you to do is convert all of them to the same unit. It's something I didn't do in the first one, and some persons even asked me, I said they should leave it like that. But I want us to do it this way. Is that okay? So that is one of the corrections that we are going to take. We are going to convert each of these to a particular unit. In this case, I want us to convert it to milliliter. Millimeter. So this 0.5 in millimeter will be what? 5 millimeter. This one, 0.625 inch in millimeter will be 1.59 milliliter. 0.5 inch milliliter is this was supposed to be not 0.65. Let me calculate again. 0.5 divided by 8, 0.065. All right, exactly. So we have 0.5 inch to millimeter. That will give us approximately 12.7 millimeter. So this is 5 millimeter. Then we have the other one here, which is 0.1 centimeter to milliliter. What will it be? 0.16 centimeter to millimeter. What do you think it will be? To give us the smallest subdivision in each of them. That is 1.6 millimeter. So in order of precision, sorry about that. In order of precision, this man fell. Let us arrange this device now, or rank them in order of their precision for that particular one, and see what it will give to us. Of course, you can see that the first one is the least precise. All right? I mean, the approximately C is the least precise, unless this marking here, they didn't mark it well. Because if you look at it very well, it's looking like 5, but it is not. If you count, this is 1. I mean, it's looking like 10, but it's not. This is 1, 2, 3, 4, 5, 6. For this one, 1, 2, 3, 4, 5, 6. Then this one 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Each of them they are 6, 6. Is that okay? So this is like 1.6 millimeter. This is 1.59 millimeter. So the one that has the lowest is the one with the highest precision, most precise. Of course, that is C. So ranking them in increasing order, D is least. So we say D is less precise than, followed by which one again? B, which is less precise than A, which is less precise than what? C. C is the more precise one. If you look at it very well critically. All right? Exactly. So that is that for this one here. Now, the next one is give the correct volume reading and length reading for the following. Now, for this particular one, listen, for the fact that they say volume at 2 mark. At 2 mark, what is the lowest reading for this particular, for A that we calculated earlier? The lowest reading for A we calculated was 0.1. So for 2 marks, it will be 0.1 times 2, which should be what? 0.2. 0.2 mil. All right? Now, the next one is 5 marks. For the 5 marks, what is the lowest value for that one? It's 0.2. So for B rather, is 0.2 mil. So it will be 0.2 times 5. So we are going to have, 0.2 times 5, that will give us 1.0 mil. All right. Then the next one is C. What was the lowest subdivision for C we calculated? 0.5 mil. All right. So at 10 marks for that one, be 0.5 times 10, which is 5.0 mil. Then for D, 1.0 mil. For D, 1.0 mil. And then you have 30 marks. That would be 30 times 1.0, which is 30.0 mil. Then for the 70 marks, E is what? The lowest subdivision in E is 1.0 also, so it will be 70.0 mil. All right? So here will be 70.0 mil. Then for F, the lowest subdivision for F is, I think, 2 mil. For F is 2 mil, G is 5 mil, and H is 10 mil. So for F is 100, at the 100 mark, the lowest subdivision for F is 2 mil. So it's going to be 100 times 2, which is of course 200.0 mil. And then for this one, G is 5 mil. At the 500 mark, G will be like 5 times 250. What will it become? 1,250 mil. And therefore H is going to be 7,000 mil at that mark. Is that okay? So that's basically what you should do in this particular one. If not, I don't. Another thing is that this thing is quite confusing in the sense that the 700 mark they are talking about, is it the 700 calibrated? The 700 calibrated, what are they expecting us to do? Or 700 mark is each of those mark multiplied by 700. Really? All right, so that is that for that particular one. Then for the other devices, the ruler, we have the 9 mark. What do you think the measurement would be? That one, we had it as 0.16 cm. So at the 9 marks, it's going to be 0.16 times 9, which is 1.44 mil. So this one will be 1.44 centimeter. Then for B, the lowest subdivision for B for this one is 0.5 centimeter. So it's going to be 0.5 times 9, which is 4.5 centimeter. 4.50 centimeter. Then for C, 0.0625 inch. We have 0.0625 times 9, which gave us 0.5625 inch. 0.5625 inch. Then for D is 0.5 inch times 9 again. That will give us 4.5 inch. All right, so that is basically everything you need to know for this particular one. Now I say give the correct readings when 2-gram mass is placed on a weighing balance A and B in figure 3.3. They gave you a particular figure there. Now for A, look at it. This is in page 19. 2-gram mass. For A, the reading for A is read to 0.000. That is 4 decimal place. All right. So for A, it's going to read 2.0000 gram. For B, it's just going to read 2.00 gram. Is that okay? Exactly. So that is that for this particular practical. Now, these readings here, they are quite like this. The expectation from this particular table is somehow vague. This particular table, because they say give the correct volume reading and length reading. They gave the volume of liquid at the second mark. Second mark, are they talking about the two calibrated or those lines then? If it is those lines, then this one is correct. Because if you say 700 mark and this smallest subdivision here is, let me look at it. The smallest subdivision for the last one was 10 mil. And the cylinder is how many? What's the capacity of the cylinder? Cylinder is 1000 mil. So it's not possible for us to get 7000 mil. But what they actually expected of us for that particular practical, this particular table, is quite obscure, like not clear. It's kind of vague. All right? Kind of vague, but let's just leave it like this. All right? Because if they just want to say as